Okay. So when you have mixture problems, there are basically two different ways to, there's two ways that you can do them. You can set them up two different ways. You can make a table, or you can just kind of reason out the equations. Now, get my pen working. Okay, so this is a mixture problem. And if you have to go on to pre-calc, you will need to know this, because it will show up in pre-calc. So we can make a table, or we can just do the equations. The equation method is, well, it's technically something that we're not going to learn yet, so but we'll do both just so you can see how they work. So we can do the table, or do it with an equation. So the way the table works for something like this is that you have some amount of something, like in this case that'd be how many pounds of whatever the nut is, and we multiply it by the price, and then that will give us basically a total here. So we've got amount times price equals total. So for example, if I bought 2 pounds of peanuts, which are $1.50 each, then that's going to cost me 2 times $1.50, and that's $3. So that's how the table gets set up. And so we put the two different types of nuts. So we have peanuts, which are technically not actually a nut, they are a legume. And then we've got walnuts. And that brings us to our mix. So I make a table. So I've got my table filled in. And I'm going to just use highlights. So this is our equals. And you multiply, and then it equals. So this is sort of how we come up with our equations. So we have this table thing going on. And then you fill in the information that you are given. So they're telling us the price of peanuts is $1.50, so I will fill that in right there. Walnuts are $2.60, and then we need our mixture is going to be $2.25 a pound. So I'm just filling in the information under price, and then we fill in what we know about the amount. It says we want 100 pounds of a mixture, so we put 100 right there. And that's all we know so far. So we've just got this. I don't want that to be that thick. Yeah. Make this thinner. So I'm putting in these lines because this is going to kind of help us fill in this table. I will switch to orange. So we need to fill in everything on the left side, the first two columns, before we can fill in the right side. And the way it works is in the amount column, we know that those have to add up to 100. So this is addition going down. Maybe I'll do that in the blue. So these are addition going down. You add, well, for the amount, not for the price. Oops. Racing too much. There we go. So we are adding going down, we're multiplying going across. And the total is also adding as well, because you add those two things together when you're getting a total, you're adding things. So we want to fill in the amount column, and so you need to pick a variable for either the peanuts or the walnuts. It doesn't matter which one you use. I usually, if I have those two blanks, I'll choose the one right above the mixture column, so above that 100. And we're kind of working backwards. So, you know, peanuts plus walnuts equals a mixture. So if you have the mixture and you subtract the walnuts, that will give you the peanuts. So you have 100 for our mixture. We subtract the walnuts, which is x. That gives us 100 minus x for peanuts. If you add the amounts of the peanuts and the walnuts, that equals 100. Now we have our price column that's already filled in. So we fill in the total, and we do that by multiplying, because the way we have it set up is when you're going across, you multiply. So I'm going to put the $1.50 first, and we multiply that by the amount. So the price times the amount. And I'm not going to actually do the multiplication, I'm just writing it. Yes, the mixtures are hard for a lot of people, but once you understand the setup, it does get a lot easier. But I'm going to show the setup with the table, and then I'll do with the equation. So I've written out the peanut row. Now the walnuts we also multiply, so that's going to be x times 260, or 260x. And then for the mixture, you're multiplying them 100 times the 225, which gives us 225. So now that you've filled in the table, you create the equation that you're going to solve by taking the total column, and you're taking the total for peanuts plus the total for walnuts, and that equals the mixture. So that's going to be an equal right there. So I have 150 times 100 minus x plus 260x, and this equals 225. And then that's your equation to solve. So then you're solving that for x, and x will tell you how many walnuts you have, and then you can find the number of peanuts. So to solve, the first thing we want to do is distribute. So I'm going to multiply that 150 through the parentheses. So $1.50 basically times 100, that's 150. Then I'm going to just eliminate the zero and just write 1.5x. Then I have 2.6x, and that equals 225. Now I'm going to add like terms on the left side, because I can add those x's. I have a negative 1.5 plus 2.6. So this will give me 150 plus, because that adds up to a 1.1. So it's going to be 1.1x equals 225. So now I want to solve for x, so I need to subtract the 150 from both sides. Whoops. So I get 1.1x equals, and then 225 minus 150, we get 75. Now I'm going to divide both sides by 1.1. And it's good because I modified the numbers, it doesn't come out perfect, but we get 68.18, and since we're looking at pounds, we'll round it to 68, we'll round it to a whole number, because we are looking for the amounts. So that is 68 pounds. Now that x is the walnuts, because I labeled walnuts x. So that is going to be 68 pounds of walnuts. Now we know that it has to add up to 100, so peanuts is 100 minus x. So I do 100 minus 68, and that will give me the number of peanuts. And so that would be 32 pounds of peanuts. And so that would be your mixture in order to get the certain price that you want to sell of this mixture of nuts. So that is the table method. Now I'm going to go to the equation method. So with the equation method, let's say that x is going to be walnuts. And let's use a second variable for the other, which is going to be peanuts. So when I use the equation method, I use two variables instead of one. And then I look at what's going on here. So we know we have 100 pounds, and it's going to be mixed out of walnuts and peanuts. So I know that x plus y is equal to 100. The pounds of walnuts plus how many pounds of peanuts, that has to equal 100 pounds. The second equation is I basically take that equation and then I multiply each variable by the respective price. So x is walnuts, and walnuts are $2.60 a pound, so I'm going to multiply that x by 260. Y is peanuts, that's $1.50, so I'm going to multiply y by $1.50. And then our mixture has 100 pounds, and that's costing $225. So I basically write one equation, which is just the total, and then I multiply each of those by their price. This would be the same thing as if it was like a percent type of problem. You'd be multiplying them by the percent. So the way this works is that you take the easier equation, the smaller equation, you solve for a variable, and you plug it in, and then you're left with what you have. So I'm going to take that x plus y equals 100, and let's say we solve for y. So when we have two variables, x and y, we like to solve for y. So I'm going to subtract x from both sides. And this gives me y equals 100 minus x. Once you have that, you then take that and replace a y in your other equation with what it's equal to. So we would end up with 260x plus 150 times y, but y is 100 minus x, and then this equals 225 times 100. You'll see that the left side is now the same thing that we had with the table, and if you multiply 225 by 100, that gets you, or 225 by 100 is 225. So we end up with the same exact equation as when you do it with a table. It's just a different method of working with the equations, or creating the equation. One is with a table, and then the other one is sort of by translating what's going on and thinking about what's going on, and then creating your equations that way. You'll solve this, you'll get the same answer. You'll get the 68 and the 32. So Rebecca, does that help you at all with that mixture stuff?
Yes, I kind of like the table better, but I think to each his own.
Yeah, that's why I showed both methods. I personally, if it involves percents, I use the table. If it involves price, I usually use the equation method. I don't know why. That's just the way that I do it. But yeah, I mean, each method works, and so I want to make sure that you guys use or know each method, and then you can use the one that works for you. So, but aside from that, you like the table method. Did that help anything else with like how to set it up, or?
It just kind of helped set it up, and then once you did the table, and then the equation made sense, so I could see both relevance. I could see how the equation works quicker than the table.
Yeah.
But during test time, I learned to do the equation part probably.
Right. Yeah. Setting up the table takes time to set that up. And then, I mean, you get to the same point. It's just how much are you willing to write down? I I don't think that you guys will have any questions like this, though, on any quizzes or midterms, though. I don't think that this is one of the things we test on, if I remember correctly. Yeah, I'm looking, the book doesn't even give you the table method, and yeah, I'm looking at the textbook. The textbook doesn't even really explain how they got their equations very well. So.
No, exactly. That's the reason why I was looking at it. I know that was last week's, but I was just still really curious on how to formulate it.
And it would be the same thing with like an interest problem. Instead of price, it's just a percent, but you're still kind of doing the same. The amount is still how much are you investing, you still have your total. So you can set it up the same way. And even with the profit equations, when it gives you with the profit, it's giving you percent. So the setup's the same. But yeah, they don't even give you, they did a very Is there anything maybe from week 1 that you guys are still confused on, or week 2, or has anybody taken a look at the week 3 stuff yet?
I started week 3 today, and sorry for interrupting if I interrupted anybody. But the aquatic formula for solving it is kind of, wouldn't mind going over that.
Okay. So by factoring quadratic equation, like the formula, or because we could solve quadratics multiple ways. We've got the quadratic formula. We can do it by factoring. We've got
extracting,
and then square roots. So which one did you say?
Let's square roots.
Okay. So the extracting square roots method?
Yes.
Or the actual formula?
I'm kind of stuck on both of those.
Okay.
I started working on these today, and so.
Okay. So we will do both. So this is called extracting square roots. This is really solving quadratics by, they use the term, the book uses the term extracting square roots. I usually just say taking square roots because that's what you're doing. You're taking a square root to an equation, and it's actually not too bad at all. It's really not so bad. So I'll do a simple type. Let's start with, I'll put 3 here. And then we'll just do that. Okay. So we've got 3 different types of problems when you're solving the quadratic by taking a square root. When you're doing the square root method, you have to have only something squared in your equation. So you're either going to have just an x squared, or you might have something in parentheses squared, but you don't have anything with just a regular x, because that means you can't use this method. So you can note that the form that we have something squared equals a number. So like something squared, I should use number. So I'll just do this. Something squared equals a number. That's sort of how you use this. And if it's not in that form, if you can put it in that form, that means you can use this method. So what this method is, you're just literally taking the square root of both sides. And quadratics always have 2 answers. So we get a positive answer and a negative answer, because if you square a negative, you get the same number as if you square the positive. Like squaring -2 gives you 4, and also squaring 2 gives you 4. So there's 2 ways to get to 4, -2 and +2. So when we take square roots, we get 2 answers. And we always use a plus and a minus sign, basically, to show that. To show that it's a positive version and a negative version. So when you square root something squared, that cancels. And then we get this is our plus minus sign. So that symbol just means that we have two answers. One of them is positive, one of them is negative. Yes, so we're going to have two answers. Then you take the square root of 225. So I picked that one because that comes out to a whole number. And the square root of 225 is 15. So you can write this as plus or minus 15, or what you can say is that we have a positive 15 and a negative 15 as our answer. Both of those work. So that plus or minus turns into basically two things, a plus and a minus version. So it's the same thing with my example in the middle, x squared equals 220. You take the square root of both sides. Now in this case, when you take the square root of 220 on your calculator, you get a decimal. So in this case, you need to leave it inside the square root because we're not going to give decimal versions unless it's basically a word problem. If it's not a word problem, we want to give it exactly. And so we need to simplify the square root. So I'm going to go on a little adventure to simplify this square root. So when I simplify square roots, I take the number that's underneath there and I make a factor tree. So I split it up into two numbers that multiply to the original number. So for 220, I know that's 22 times 10. And then I split those up. So 22 is 2 times 11. And if those are, when you get to a prime number, I circle it. And then 10 is 2 times 5. So I'm going to rewrite this. I have x equals plus or minus, and then instead of 220, I'm going to take my numbers that I have in my tree. I'm going to start with the lowest number, and I have two 2's, so that'd be 2 times 2, so that's 2 squared. And then I have a 5, and then I have an 11. So I'm just rewriting my square root so that I have 2 squared times 5 times 11. If you do that math, you'll get 220. Now, if I can take the square root of 2 squared, those cancels out a square. And when you do that, that number leaves the square root symbol. So when I take that square root, 2 squared, the squared cancels. I'm left with the 2 that's underneath. That leaves the square root symbol. And then I have 5 times 11. And I can't simplify those because they're not in powers of 2 for a square root. So then my last step would be to multiply those. So 5 times 11 is 55. Let's see, is anybody having sound problems or?
Nope, not me. I can hear and you
Okay.
guys.
So it might just be on DeAndre's end. So maybe you might need to try calling in, or maybe use a different browser, or maybe a different computer or something.
He can maybe try to refresh and come back in too.
That's an idea as well. Yeah, so as long as it's not on my end, if not everybody's having a problem, then it's probably, it could be just Blackboard's been having issues. I had some problems earlier today with Blackboard. So I know the first one that I did was pretty straightforward. The second one took some extra time. Do you guys have questions on the example I just did?
Nope.
Okay. So now I'm going to do the third one that I have here, where I have the x minus 5 in parentheses. So same thing. you're going to take the square root of both sides. And that still cancels out the square. And what happens is you're left is what's inside the parentheses, which is just the x minus 5. And then we get our plus or minus, and then we get 49. Or square root of 49, which comes out to 7. Now I have to, yes, question?
So when you said that the square root cancels out, like, is that like putting the 2 in front of the square root on both on that side?
Yeah, so like a square root always has that 2. So because of that, these things basically cancel out.
Ah, okay. Okay, I got it.
Yep. So in this case, I'd be adding 5 to both sides, but the plus or minus gives us an issue there. So you can't just add the 5 to 7 because of the plus or minus in front of there. So we have to create 2 equations. One of them with the positive version and then one with the negative version. This might be familiar. We did something similar with absolute. No, we haven't done that yet. We're doing. I'm like, wait a minute, we haven't gotten that. That's this week. So you will be doing this again in another section this week. So we get this plus or minus. We get 2 equations, and then we solve both of those for x. So I'm adding 5 to both sides, and it's the same on both equations.
You're the only thing.
We just get different numbers. So our first number is 7 plus 5, we get 12. And then in the other one, we have negative 7 plus 5 is negative 2. So we still get 2 answers, but they're not like just a plus or minus version of each other, and that's because we have that minus 5. Are there any questions? Rebecca, I know you had this question. Does that help you out?
Yes, it did help. The last problem you did is where I'm struggling the most at when I was trying to figure it out because of that negative in there. I was trying to think too hard. So that does help and explain it better. Thank you.
Okay, perfect. And if I do a quadratic formula one, you'll see that plus or minus plays the same kind of role. So I'll do one of those. So let's see. So we got 2x squared minus 3x minus 1 equals 0. So the quadratic formula you use, I mean, you can use it all the time, but we basically use it when we have something in this form, where you have some a, which is just some number. So a number times x squared plus a number times, and then plus another number. So like in my example, 2, negative 3, and negative 1, those are our values here. And I always make sure to write those. So this 2, that is going to be a, because that's the number in front of the squared term. And then you include the negative if there's 1 involved. So b is a negative 3. And then I'm including the negative, so c is negative 1. So the quadratic formula is, let me put this in pink so it kind of matches. X equals, and if you had something instead of x, like if you had t or if you had w or whatever you have in your equation, then it would be w equals negative b. There's that plus or minus symbol. Then we have a square root, and all of this is inside the square root. B squared minus 4 times a times c. So that's all inside the square root. And then all of that is over 2 times a. So the key is knowing what A, B, and C are so that you can plug them in. And then once you plug them in, you're following the order of operations. So I've already labeled my my A, my B, and my C. So I'm going to set this up. So it's negative B. So if B is already negative, you're going to end up with a positive there. They're going to cancel out. So a lot of people get confused there, so I like to put it in parentheses because we have a negative and then B itself is negative. Now I'm going to have my square root. So we have B squared, and anything with negatives, put parentheses around them so you can make sure you're squaring them properly. So that's negative 3 squared, and that's how you'd have to do it on like a calculator. Then minus 4, and then that's times A, which is 2. And times C, which is negative 1. And then that whole thing is over 2 times A, which is also 2. So if I try to color code everything that is A, that's in yellow. Let's say B is going to be in green. So everywhere B shows up in the formula, that's green. And then C, that only shows up in the formula in one spot, and that's in blue. So you can kind of color code if you need to kind of help you keep track of where all the numbers are going. From here, people often start, the biggest mistake is usually a math from here. So it's not so much the setting up, it's the math. So first thing is that I have a negative in front of a negative 3. So those cancel out, so that just becomes a positive 3. So that's going to be the first thing that I'm going to do. And then you want to start simplifying inside the square root. So order of operations is PEMDAS. So parentheses is if you have things added inside parentheses, which we don't have. Or if you have things like multiplied, if you have other things going on inside parentheses. But everything we have in parentheses is just a number, so we don't need that step. So the next step is the exponent. So we have this negative 3 squared. So that's negative 3 times negative 3, so that's going to give us 9. And then I'm going to write this minus 4 times 2 times negative 1. And it's easy enough to just do the 2 times 2 on the bottom because that's the only thing you need to do in the denominator, so I usually just do that right away. So now I've taken care of my exponents. Next is multiplication and division. We don't have any division, so we're just going to do the multiplication that's inside the square root. So I need to copy everything down. And when you're doing the homework for week 3, I recommend not typing it because trying to type all this up would be really a pain in the butt. So if you just do it on paper, it'll make your life so much easier.
Yeah, I can't do the typing. I have to work it out. That's the only way I can do it. I can't do it like that.
I think even doing it by hand helps you understand it better. I think if you're typing, you get so like carried away with what you're typing that it doesn't like stick in your brain. So I'm multiplying this minus 4, so that's a negative 4. So you can just do all of that on your calculator. You've got a negative 4 times 2, which gives you negative 8, and then a negative 8 times a negative 1, so that becomes a positive 8. So that becomes 9 plus 8. And then I've got this over 4. And I don't like having my square root too long, so I'm going to correct that. So that's it. We don't have any division in that point. So next is the addition and subtraction. So we just have addition there. So we're going to add the 9 plus 8. So that gives us 17. So I have the square root of 17 over 4. So now the square root of 17 is a prime number. So that we can't simplify that square root. If you did have something else, you'd have to simplify it the same way we did this one in the middle. You'd want to simplify that square root, but 17 in this case can't be simplified. So we get two answers out of here, and so what we need to do is split it up into two equations again. One with the plus version, and then one with the negative version. And what we generally do is that instead of writing it as a single fraction, we generally will split each fraction apart so that if you need to simplify, you can. Like sometimes things can get canceled out if you split it apart. So we will generally do that. And so we end up with two very nasty looking answers. And you get nasty answers for anything that you can't factor. So if you can't factor it, you can use the quadratic formula and it's going to look gross. And it's going to end up with decimals if you tried to come out with actually do the square roots. Let me actually finish my other arrow there. So that is the quadratic formula. And you can see that it has some similarities to sort of what we were doing here where you have the square roots. And that square root is coming about because you have this x squared in there. It's just a specific formula that occurs when you have things beyond just the x squared. Are there any questions?
I'm still kind of having trouble with the slope.
Okay.
Like
Something slope.
like the assignment we have now for the for the last one we had, the line that passes through the slope.
Okay.
I guess for me, I think I might be messing up the formula or not doing the formula properly.
Sure. Okay. Let me find. I mean, I could just make up numbers, but they're probably going to be really gross. So I don't want to just make up random numbers. And I'm assuming DeAndre, is it DeAndre? I'm sorry, I probably am butchering that, but I'm assuming your
Yes,
sound. How is it pronounced?
DeAndre.
DeAndre. So I did okay. So I had it right, and then I second guessed myself. Okay. Yeah. So let me find. So let's pick one that's going through 2 points. So slope of a line through 2 points. All right, let's actually find the equation of a line, and then we'll find the slope to get there. So we'll do the equation of a line through 2 points, because you have to find the slope first, and then go from there. So let's say we have 2, -1, and then -6 and 4. So our equation for a line, generally we have it in mx plus b format. But in order to use that, you need to know the slope, which is m, and then the y-intercept, which is b. Most of the time we don't know the y-intercept, so we use point slope form, which is y minus y1 equals m times x minus x1. So you still need to figure out the slope, but then all you need is one of your points, and you can plug that in, and then you get your equation. So if you have 2 points, I will label them. The first point is x1 and y1, and then the second point will be x2 and y2, so that you just have your points labeled. That's helpful
Now,
when you have.
mandatory to have the first set x1 and y1?
Yes. Yeah, and it actually doesn't matter which ones you do. If I wanted to, I could make the second set x1 and y1, but then that's just weird, you know, because it's like backwards. But you actually get the same answer either way. So our formula for slope is y2 minus y1 over x2 minus x1. And those numbers, if they're below a variable, are just labels. So it's just labeling first point, second point. That's all it's doing. So my y2 I labeled as 4. So 4 minus, and then negative 1, which is the y1. And then my x2 is negative 6 minus x1, which is 2. So on the top, 4 minus negative 1 is actually addition. You're actually adding 1. So 4 plus 1 is 5. And then a negative 6 minus 2 more gives you negative 8. And so we generally will put the negative in the middle and say that's negative 5 over 8 for our slope. If you can reduce that, you can. This number does not reduce, and we generally don't turn it into a decimal unless it's involving real data or real numbers, real word, like a word problem. So like for our discussion for week 2, that you'd make it a decimal if you could, because it's using real data. But if it's not real data, we usually leave it as a fraction. So now that I have found my slope, I'm going to put this and plug it into my point slope form. So point slope form is y minus y1. So the y1 I labeled as negative 1. So I'm going to use that same y1. And then our slope, the m, is negative 5 over 8. And then parenthesis, and then x, and then x1 is 2. So you don't plug in for x and y. You only plug in for x1 and y1 because we want our equation to have x and y. So on the left, when I have subtracting a negative, that's adding. So that's going to be y plus 1 on the left. And then on the right, you want to distribute through the parentheses. So we get a negative 5 over 8 times x. So that's negative 5 over 8 x. And then negative 5 over 8 times a negative 2. So those two negatives cancel. You get a positive. And when you have a fraction times a whole number, the whole number gets multiplied by the top of the fraction. So that would be 5 times 2. So that's equal to 10 over 8. And we're going to want to reduce 10 over 8. So I'm going to just rewrite this. So 10 over 8, I can divide 2 out of both of those numbers. And so that gives me 5 over 4. So I have y plus 1 equals negative 5 over 8x plus 5 over 4. Now I'm going to want to subtract 1 from both sides. And this is where we get in a little issue because we have a fraction. Now you're going to have to work with some fractions. So y equals negative 5 over 8x. And then I'm going to just write what I have. We have 5/4 and we want to subtract 1. So we want 1. We want to first make it a fraction so that we can subtract. And then you need to have a common denominator. So since the denominator is 4, I need to multiply my 1 over 1 that I got from the 1. A lot of ones there. I need to multiply the top and the bottom by 4 so I can have that common denominator. So this gives me y equals negative 5 over 8x plus 5/4 minus 4/4. So now that you have a common denominator, you can do the subtraction. 5 minus 4 is 1, so you end up with 1/4. So that gives us our equation in slope-intercept form. We get y equals negative 5 over 8x plus 1 over 4. If you have a calculator that can do fractions, I would say go ahead and let the calculator do the fractions for you. because that way you're just, it eliminates possible areas in making mistakes. But if you want to do it by hand, that's how you do it by hand when you have things involving fractions.
So I actually have a question about the slope itself.
Yeah.
When you go up and put, the y2, why not y1 first and x1 first?
You can if you wanted to do y1 minus y2 and x1 minus x2, you will get the same answer for slope. So let's test this out.
Okay.
So they just do 2 minus 1 because whenever the distance formula, we're always doing like x2 minus x1. We're always subtracting that way, usually because it tends to produce positive numbers more than negative numbers. But if you decide to do it the other way, you will get the same answer, just as long as you match it. Oh, see, it's so weird for me to do it on the other way. I'm not used to writing it. So, like, if I do it the other way, my y1 is -1, subtracting my y. Oh, this is so weird. It's like working my brain. See, x1 is 2 minus x2, so that's -6. So we get a -5. 2 minus a -6 is a +8. So the negative ends up with the other number, but the value is the same. You still get -5/8. So if that makes more sense to you to subtract it that way, you can go ahead, just as long as you do the same order for both the x and the y. If you flip-flopped one of them, then that would mess you up.
Right.
But that was a real brain test for me, trying to do it in the opposite order. Does that help you understand slope and the equation and all that?
Yes.
Good. DeAndre, did that help you as well?
Yes, it definitely does.
Cool. What other things do you guys want to see or that you might need help on? This has been very productive. I'm really pleased about this.
Since you're here, can you just work through some of the radicals that we went through? The radicals seem to be my speed.
Sure. Do you want to do like a simplifying radical, or we're going to be working with radicals again this week when we're going to be solving radical equations? So which of the two, what do you want to see?
So let's go with a simplified radical, just so I get the foundation.
Perfect. Okay, so let me get to that in the book. I really wish I could that there was a way that I could just get an infinite number of questions of the type that I want. That would be so nice. Okay. So luckily, most of the stuff we're going to be doing with like square roots and everything going forward will be mostly just involving numbers and not variables as well. But we will look at these variables. I don't think I did this one yet. Square root of 72x cubed. And then let's see how that changes if it's a cubed root, just so you can see how that matters. So with a square root, your goal is to make everything in pairs. So that has an exponent of 2. With a cubed root, you want to have everything to have an exponent of 3. So I always start with taking my number that's underneath there and doing the factor tree. So I'm going to start with that 72. I'm actually going to do this in the middle because it's going to be the same for both of these. So 72 is 9 times 8. I had to think about that. I was like thinking, I almost pulled out my fingers. I don't know if you guys know the finger trips for nines, but I almost just pulled those out. Let's see, 9 is 3 times 3, and those are prime numbers, so I'm going to circle those. 8 is 4 times 2, and 4 is not prime, so I need to split that one up. So that's 2 times 2, and then I have that other 2. So I'm going to take my radical, and instead of writing 72, I'm going to start with the lowest number. So I have 2 and 2 times 2. So there's 3 of those, so that's going to be 2 to the 3rd power. And then I've got a 3 times 3, so that's going to be 3 squared. And now I have this x cubed. You want to be able to split that up the same sort of way. So I'll just put this over here. So x cubed, if you think about it, it's just x times x times x. So for a square root problem, you want to group them in pairs. So we're going to group 2 of them together, and then we have an x left over. So I'm going to take that x cubed, and I'm going to turn into x squared times x, because that way I can group it in pairs. Now, if I was doing this with the cubed root problem, I don't need to do that because, well, let me write my 72 is 2 cubed times 3 squared. But for a cubed root, I would leave it as x to the 3rd because I want exponents of 3. So what the radical is, whether it's a square root or a cubed root or like a 4th or a 5th, that's how you want to group it, and that determines how you split up your variables. The numbers get split up the same way. So going back to the square root, let's do this. So that square root, you can think of it as having that 2, just like the cubed root has that 3. So anything that has an exponent of 2 can be canceled out and pulled outside of your radical. And then you're left with what's underneath. So like the 3 squared, because I have a square root, that can get canceled out, and I'm left with just a 3. And then the x squared, that can get canceled out because I'm taking a square root, and I'm just an x. And then what I'm left with inside is this 2 cubed times x. So now this 2 cubed, one thing that sometimes when I go through these, you know, like I'm going through the motions, and I'm like, well, wait a minute here. The exponent on my 2 cubed, that's higher than my root. So that means I can split it up just like I did the x cubed. So instead of doing 2 cubed, I can do 2 squared times 2, so that I can have them in pairs of 2s. So I would have my 3x, and then I could write this as 2 squared times 2, and then x. Now, had I been thinking ahead, I would have done that in the very first step when I did the prime factorization, but I did not. So you can kind of fix, if you don't realize something right away, you can fix it later on. You can still work with it.
This is helpful on this route too.
Good. So once I see that, I say, okay, my exponent's higher, so I can still split it up. So now I've got something, and this, you know, it's a square root, so that means I can basically, those match, I can cancel them out, and then I can pull that in front. So that's 3 times x, that's times a 2, and then I have my square root, and now I'm left with 2x inside there. My exponents there, I have no exponents, so I'm okay, that's simplified. But in front, I've got this 3 and the 2 that I can multiply together. So that will give me 6x, and then you have the square root of 2x. And it's gross, as most things do when you have square roots, but it is technically simplified. So if I move over to the cubed root, it's the same sort of process, but now you're looking at exponents of 3. So a cubed root cancels out an exponent of 3. So I have a 2 cubed. That exponent gets canceled out. I'm left with a 2. And then I have that x cubed word, it gets canceled out, and that leaves me with an x. And then I have my cubed root, and then I have a 3 squared. If the exponent is smaller than the root, that means you can't simplify that further. So because my exponent is 2, which is smaller than the 3 on the outside, I can't simplify that anymore. And so what we generally do is then square that number so that we don't leave it in exponent form. So you have 2x, and then your cubed root, and that would be 9. So you can see how you can have the same thing, and that simple number outside, saying whether it's a square root or a cubed root, dramatically changes your answer. It sort of changes, your approach is similar. You're still trying to group things up by an exponent, but how you do it changes, basically. You know, what it looks like changes.
Right, the foundation changes, like the ground floor.
Mm-hmm.
Well, based on that.
Yeah. The key for algebra is to be able to see the similarities and the patterns, because math is all about patterns. And if you do a whole bunch of problems like this, the key is to see, okay, my steps are generally the same. It looks differently, but the overall process is the same. We were trying to group them up so that the exponent matched what the root was. And then you canceled out that exponent by taking the root and it goes on the outside. So the process for both is the same, even though they look different. And if you can learn the process versus what every single problem looks like, that will make you more successful at learning math and learning algebra, because algebra is all about learning procedures and then be able to know that, oh, this is this type of problem, so it's the same steps in this situation. Even if it looks completely different, it gives you you know what to do. And this actually does apply to real life, because a lot of times in real life you may know a certain step of procedures, you know, like say you're in a hospital, you're like, okay, when this happens, I know this is what I do. You have to be able to recognize when those same steps are needed, even if it's a completely different situation. You know, you're going to have a different mix of, you know, maybe somebody's numbers are different. You know, maybe that you're looking at kidney levels and you're like, if their kidney is this way, you do this, and you know, but you need to be able to understand, okay, I still have to apply the same steps, even though the situation is completely different. So that's sort of what algebra is all about, is paying attention to the big picture and what the process is, and learning the process, and then being able to apply that process to different situations, which is really what problem solving and critical thinking is all about. And while you may wonder, why am I ever going to need this? You're probably not going to be simplifying radicals in your job. But the thinking process that you're learning from all of this, you will be using. And so that's one of the reasons why everybody is forced to take algebra, is because of the thinking process, less the actual stuff.
Thank you. That was very helpful.
Good, good. Yeah, and Cassie says that she was simpling out the wrong numbers, and or canceling it out, and that's an easy mistake to make. It's not, you know, canceling out the wrong things. So that's why I try to use color coding or highlighting, because that helps me. Is if I can highlight a color code, that helps me see what's going on there and kind of follow the process. And another thing that helps is, like, I don't do it when I'm writing things out, but if you're like taking notes, if you write down the steps that I did, and, you know, write down why. Like, we did prime factorization so that we can look at the exponents, or we want our exponents being pairs because this is a square root. You know, if you write those things down, that helps you pay attention to the process, because you're not just writing down the problem, you're writing down the important steps that tell you what to do. So that way you can follow those later on when you see something that's also a square root or also a cubed root. So that brings us to 8. I usually don't like to do these more than an hour because people's brains get fried doing an hour of math at a time. I mean, even in my brain, sometimes if I spend more than an hour on something, I'm like, okay, I need a break. So, but you guys, oh yeah, for homework, you can use highlighters. That's completely fine. You use highlighters. You can use colored pencils, colored pens. Do I have, I'm actually wondering if I have any examples of how I can show you. Nope, that's not colored. These are not, none of these have colors. I have all these math problems in front of me. That's not color coded. I sort of color coded this. I boxed things. Yeah, keeping your math in order is really important. Binder, I have a binder usually, but I brought all these home from the office and I took them out of my binder because I didn't want to carry a whole bunch of binders. I highlighted my answers in this one that I did. I'm trying to find, do I use colors in any of these that I brought home? Apparently not. I do it when I'm teaching though. But yeah, you can use colors, whatever, as long as your math that you're submitting in your homework is in order, so the problems are in order, and that makes it so much easier for us to grade, easy to read, you know, not smushed up if you have lots of space. Don't be afraid to use lots of pages for math. You'll find that if you leave yourself lots of room and you don't try to smush things together, it'll actually make more sense to you. If you try to smush it together, it's hard to keep track of what's going on. I recommend a lot of people use graph paper. I have graph paper. I have too much stuff on my desk. I've got graph paper right here. It's really great when you're stuck because you can keep everything in line. So it keeps things nice and neat. So that's another recommendation is if you have graph paper. If you don't, you can always print graph paper off the internet that have that. So those are my tips for you guys. Yeah. So thank you guys for coming, asking questions. And I like that, you know, and it's not like we can answer. I can answer questions about any week, you know, whatever you're struggling with. All right. So you guys have a great night. I will post this tomorrow. I'll probably do some editing. I don't know if I'm going to edit each topic into a different video or how I'm going to do that. But I hope you guys have a great night.